Okay, areas of regular polygons. First of all, we need to know what a regular polygon is. What is a regular polygon? It's a polygon with congruent sides and angles. That is your formula. The A is called the apothem. The capital P is called, what is that called? Probably don't need to define perimeter, do I? Apothem, we probably need to go into a little more detail, don't we? So let's talk about the apothem and what it is. It is the distance from the midpoint of a side to the center of the polygon. Perimeter is the distance around, correct? There is another one we need to talk about here. And it is called the radius. You kind of do. It is the distance, and you're right, from the vertex of a polygon to the center of the polygon. On a special note, the radius always bisects that vertex angle. Kind of making you write down some things here that you probably are saying, well, what is this and why does it matter? Well, we're going to write down it in words, and then we're going to break down the picture of each. Okay? All right. One more thing to write down about the apothem. The apothem is always perpendicular to the side. What are these all examples of right here? Nope, more specifically. Okay, for right now, I don't expect you to write these down because I'd rather you listen to me. Okay?
What's the second word that's underlined? Okay.
Bisects. Regular polygons. Before we worry about apothem and radius, I want to do some review of regular polygons. What did I say is true about all of these? What makes something a regular polygon? And the angles are all what? Congruent, yes. Congruent is really the better word there. See that a little better? So for this regular three-sided figure, that's all true, correct? Any questions there? So for this regular four-sided figure, that's all true, right? For this regular five-sided, if it's regular, that is all true. Are we all on the same page there? Okay? and so on and so on. So we're all fine with all the angles being congruent and all the sides being congruent. You guys remember that?
So we do that on
No, I told you guys not to necessarily write them down right now, because I'd rather you take the time listening than, drawing all of these, okay?
oh, my bad, like on our assignment.
On your assignment, you don't have to write that down. But we're all in understanding, right? Okay. What I would like to talk about is, you guys remember what we would say n is equal to here? N is we've done this before, is the number of sides. What is n in this case? What is n in this case? Very good. What is n in this case? What is n in this case? Let's see if I can trick you. What's n in this case? What is n in this case? What is n in this case? What is n in this case?
Seven.
Yep, it's 7. It's okay. All right. So those are a bunch of different regular polygons, correct? Do you guys remember that you can find the measure of the interior angles of each of those? We did a thing where we said, hey, guess what? The sum of the interior angles of any polygon is n minus 2 times 180, right? But since they're all the same, how many angles are there when n is 3? How many angles are there? 3, right? So you divide that by what? By n, yes. This is our formula for the vertex angle of a regular what? So what I want us to do is I want us to figure out, okay, we've got the number of sides. There are what? 3 of them. For that one, what would the angles be equal to? Well, it would be 3 minus 2 times what? 180 divided by 3. What do you guys get? I'm not making you write this down. The least you can do is get a calculator out and do this, correct? Would you agree with that? So the angles are what? 60. That's because I went 3 minus 2 times 180 divided by what? N, which is 3. Well, when it's 4, what am I going to do? 4 minus 2 times what? 180 divided by what? What do the angles end up equaling? Well, what about when n is 5? I'm going to do what? 5 minus 2 times what? 180 divided by 5. What do the angles end up equaling? Very good. When n is 6, it would be what? 6 minus 2 times what? 180 divided by 6. What do you get the angles equal to here? Down here. 7, so I'd go what? 7 minus 2 times what? Divided by? What do you get your angles to be? Huh? Nope. Well, you just forgot the minus 2. It's approximate, isn't it? Is that what everybody else got?
That's what I got, yeah.
Okay, what about when n is 8? 8 minus 2 times what? 180 divided by 8. Huh? So all the interior angles are 135 degrees. How about when n is 9? You guys remember we made a table with this, didn't we? You get the angles you say equal to what?
144.
And of course, we could go on, but we're not going to. Because what I'd rather do is talk about the apothem and perimeter. Okay, what we're going to do is I want to draw the apothem and the radius for each of these and look at what type of triangle we created. Okay? So let's start with a regular triangle. If I was to draw the apothem there, what is the apothem? What does your note say an apothem is?
Distance from the midpoint of side to the center of the polygon.
So did I do that right there?
Yes.
And what did I say the apothem is? I said it's what? What did we also say down there? Perpendicular. And it's the midpoint, so that means it cuts it in what? So that's what the apothem does right there, isn't it? Everybody in agreement?
Yeah.
Okay. The radius goes from what?
The midpoint,
No. What does it say about radius?
the distance from the vertex to the center of the polygon.
Okay. So, there to there, right? So the vertex, which is right here, to the center. So that's the apothem. That's the radius, isn't it? And what did I say the radius did?
The radius always bisects the vertex.
So since each of those are 60 degrees, what is the measure of this?
30.
Because the radius always cuts it in half, right?
You do.
So that's 30. What does it make this angle? So in a regular triangle, the radius and the apothem create a what? 30, 60, 90 triangle. Look what I've got to back up again on the left of the board there. Our rules for what? 30, 60, 90 triangles. So you can see how this would make some fun problems, huh?
Yeah.
So if you're going to use this formula, apothem times perimeter, you can use 30, 60, 90 triangle to find half of the side and then the other side, half of the other side, right? In other words, you can use it to find if this was x and this was x, because they're the same, right? Then the whole thing would be what? 2x, right? So if you used, let's say they gave you the radius and you found that this was 5, you'd know this was 5, and you'd know now the whole side is what? And therefore the perimeter is 10, 10, and 10 is 30, right? So you can see how this would be a very good way for us to teach problem solving and reinforce a bunch of right triangles again, right? Fun, huh? Well, so that's what happens with a what? 3-sided. Let's be a little quicker about it here so we don't just take all night. There's my center. Let's draw the apothem. It creates a right angle and cuts this in half, doesn't it? Let's draw the radius. What is each angle? 90 degrees. So what does it make this then? That 45 and making this what? Well, looky there. What does a regular quadrilateral, what do the apothem and radius make there? What kind of triangle? (45, 45, 90), right? Here it made a what? 30, 60, what? So let's go on to the next one. Let's go on to a pentagon. Right there's our center. Let's draw the apothem. Apothem's going to go from the center to the midpoint, right? And make a what kind of angle? And since it's going to make a right angle, and since it goes to the midpoint, it cuts this in half, does it not? Well, how about the radius? Then when I draw the radius, it's going to go to the vertex. And what's it going to do to that angle? It's going to cut it in half. The vertex angles are 108 degrees. So what does it make this angle? Is there anything special about a 36, 54, 90 right triangle? Any special rules? There isn't. But you know what rules you can probably use here? Cosine of x is equal to what? Adjacent over what? Tangent of x is equal to what? Opposite over what? SOHCAHTOA. So no special right triangles there, but because it makes a right triangle and we know the angles, we can use trig functions probably, can't we? So it's all going to change by what type of regular polygon you're dealing with, isn't it? There's our center. First, I'm going to draw my apothem, which goes from the center to what? Looks a little better. What does it always do? It's always perpendicular, and it always cuts it in. When I draw the radius, it always bisects it. Well, this is a hexagon. Hexagon, each of these are what? So what does that make this angle? Cuts it in half, right? What does that make this angle? So in a hexagon, a six-sided one, what are you going to use? Makes a 30, 60, 90 right triangle, doesn't it? Isn't that fun? Let you in on the hint with all the rest of them. I don't think there's any more. In fact, I know there isn't any more special right triangles created. All the rest of them, I'm probably going to have to use what? SOHCAHTOA. Trig functions. In fact, we won't even do the seven one, okay? I don't think there are any on there, but if there is, we would just use 128.6. All right, she talked me into it. Do you see the pattern kind of forming on what you do when finding the area of a regular polygon? What's half of that? 64.3 degrees. Use SOHCAHTOA, right? Over to this one. And as you can see, I don't have to necessarily always draw it to the side on the bottom. It's just, I guess it's normally done that way. Creates a what? Right angle and cuts it in. Now the nice thing is, that's 135. What does it make this one? 67.5? Agreed? Next one. Makes a what? Right angle and cuts it in. Then when we draw the radius, what does it do? Cuts the angle in half. What are the angles here? 140 degrees. So it makes this what? 70 degrees. also cuts this in. What's crazy is we haven't even done an area yet. We're almost out of time, right? So that would be 72. Okay, here's the deal. Look at that formula. Is that a hard formula? Is it hard to find the perimeter when all the sides are the same? No. If you got a 5-sided figure and all the sides are the same and the sides are 6, all you do is 5 times 6, right? It's 30. So on and so on. Putting the numbers into that formula is the easy part, isn't it? Would you guys agree with that? The hard part is using this stuff to find what you need, using the apothem. Whether it's 45-45, whether it's trig functions, whether it's... And if you look at number 1, look at number 1 on your worksheet. Did I already give you the apothem?
Yes.
Did I give you everything you need to easily find the perimeter?
Yeah.
Those are easy. Do you think I expect to see the formula written out?
Oh, yeah.
Oh, yeah, is right. Do I expect to see how you found the perimeter? Yeah. What was it? Is it how many sided figure is it?
3.
N is 3. What's each side?
8.
So hard to write 3.8, meaning 3 times 8 equals P. Right. Make sure you write N is equal to 3 on it, or, something to indicate that it has 3 sides. And then every problem I expect you to write what the apothem is and the blank I've given there, even when it's given to you, right?
Yeah.
And perimeter. When do you think it's going to get a little harder?
Later.
Well, the problem's where I give you the radius, maybe, and that's all. Now I can use trig functions to find half of the side and the apothem. Okay, we're almost classes. What time does class get out?
Like 11.
Oh, so we do have time. Let's do some examples. Any questions, though? Do you see what we're doing here each time? I will save this and upload it to where you could use this as an example to look and see what kind of triangle you should have made each time, right? For this sided figure, for this sided, so on and so on. Ooh, I don't want to do that. We will do number 7. Okay. We'll start with number 1, though, the one we were just talking about. First thing, what's been given to me? Well, actually, what should we always do first? We should probably read our directions, shouldn't we?
Yeah.
Okay, it says, I drew the right triangle created by the apothem and the radius on each problem. Some problems may need it, some may not. But assume each is a right triangle and at the center of the regular polygon. And it also says, if you don't show all steps and work, don't bother turning it in. We're going to find the area and round to the nearest tenth. Okay. So I need the apothem and perimeter. Has any of those been given to me? What is this side that's been given to me right here? What does this represent? That is the apothem, isn't it? Well, goody gumdrops. That's been given to me, hadn't it? What about this one? What does this 8 represent? The length of that whole side, right? So since it's regular, that makes this 8 and this 8, right? So the perimeter would be 8 times what? Or 8 plus 8 plus 8. What do you get? Wow, that's awesome. They're not done. They ask you to find the area. But I mean, for all intents and purposes, aren't you close to done? 1/2. What's the apothem? 2.3. What's the perimeter? I expect you to write that out. The rest can be done inside your what? Calculator, preferably. 2.3 times what? 24 equals that. And then I divide by what? 27.6. There are no units, so we're just going to say square units. And you box in your answer. That's rather simple, isn't it? So once you get the apothem and perimeter, it's simple as simple gets, right?
Yeah, I get it.
Right. So for the ones where I've given you the apothem and then a side, all you gotta do is find the perimeter and plug it in. However, that's not always going to be the case.
Number 4.
Number 4 has just got uglier numbers. But all you still, it's just 16, however many sides there are, right?
So with the
The apothem is the distance from the center to the midpoint.
so it'd be that the 8.
8 square roots of 3. So as you can see, but then we get to number 7. What did I not give you on 7 that I gave you on 6?
The perimeter, and then we
Or basically a way to find the perimeter directly, correct? I gave you a length of the side on 6. On 7, I just gave you the apothem. Okay, this is where I want your pencils down. I will screenshot this and upload it to where you can have it. But I want you paying attention. Our directions are to round to the nearest tenth. What's nice about rounding to the nearest tenth? Well, that means that I don't have to leave it in simplest radical form, doesn't it? So I don't necessarily have, I can multiply this out, and in the end, don't have to worry so much about keeping it in perfect, radical form. However, I'd keep it in this form as long as possible, or round. If you round to the 10th, I'd take it to 4 or 5 decimal places when you're doing numbers. So let's talk about what's been given to us. What's been given to us? Well, the apothem. The apothem is right here, is it not? So it's 15 square root of what? 3 over 2. And I expect this to be written in every time. At this point, what do I need to do? I have to figure out what type of what? What type of triangle was created by the apothem and the radius, correct? How many sides does this have? Has 6 sides. So let's go back to our notes. 3 sides, the apothem and radius make a 30, 60, 90, right? 4 sides, 45, 45, 90. 5 sides, 54, 36, 90. Probably use trig functions, right? 6 sides, what? What type do we have? 30, 60, 90. So I know that this is the 60-degree angle and this is the 30-degree angle, correct? Any questions there? I also know that this is cut in half, don't I? So if I can find, we'll call this X, this would be X, and the whole thing would be what? 2 times X, right? Double it. So I need to find X, don't I? And I have a 30, 60, 90 triangle. This is where you kind of separate. I personally would separate it into a different type of problem. In other words, this is now just a separate 30, 60, 90 problem, isn't it? Well, what I always have you guys do, label them, right? Which one is the S, the shorter leg? Which one is S? Everyone stop writing and look up here. I said that before, didn't I? Sit up. What is the S? Well, yeah, that would be X because it's opposite the smallest angle. So that's your what? Shorter leg. What's your longer leg? Square root of 3. Yeah, your apothem is the longer leg, isn't it? What is the radius? It's your what? Hypotenuse. Our rule in a 30, 60, 90 is always to find what first. And it turns out S is what we need anyway. We don't have to find the hypotenuse, do we? There may be somewhere we need to. Well, for this one, so S, what does it say up there on the board? S is either the longer leg divided by square root of 3, or it's what? H divided by 2. Which one have I been given a number for? So it would be 15 square roots of 3 over 2 divided by what? Now that looks very, very ugly, does it not? Here's one thing to remember. You leave your answer in tenths, can't you? So I could put this as a decimal if I wanted to. Hey, what's going to happen? Excuse me. What's going to happen nicely here is you're probably going to get 7.5 when you put it into your calculator. If you went 15 times square root of 3 divided by 2 equals, and then went divided by square root of 3, I bet you get 7.5. Do you know why you get 7.5? Well, I could put this over 1, right? You guys remember when you were learning about dividing and multiplying fractions, right? You can't divide fractions. So you change division into multiplication by flipping the denominator. So that's the same thing as saying 15 square roots of 3 over 2 times, when I flip the bottom, it becomes 1 over what? What happens to your square roots of 3? Leaving 15 over 2, which is what? 7.5. Correct? So it makes this 7.5. What does it make this part? So what does it make the whole side? Now, with me finding the length of that side, now does it look like number 6? It does, doesn't it? I've been given the apothem, and now I've been given a length of a side to find the what? Perimeter. So I can come over here and find the perimeter by saying, let's say each side is 15. How many sides are there? 1, 2, 3, 4, 5. So what would the perimeter be? Which is 90. So how am I going to now find the area? Area is equal to what? 1/2 apothem. Stop. Oh. 15 square roots of what? 3 divided by what? Times the perimeter, which is what? That's just a big ugly mess, isn't it? Well, I mean, it's basically, if you're curious about how to do this on a calculator, it'd be 15 times square root of 3 times 90. And what's on the bottom? 2 times what? So it's all of that over 4, right? Now, you don't have to write all of this out on yours. I'm kind of doing that so you can see how I put it into the calculator in case. So I'd say 15 times what? 3 square root times 90 divided by what? 4? 584.6? Yes, it will. That's why I told you you didn't have to write it down. And we'll do a couple more examples that I'll put on the calendar too. I think it is. I think this is the first example I did from the last, you know how I put stuff on from last year. I think that's on there as well. Now, back to this, which I would like to finish I should have written this down here. When it's like this, what am I going to use? If I write SOHCAHTOA, is that all right? Trig functions. For this one, I'm going to use what? SOHCAH what? Trig functions. For one like this, I would use what? And we'll do one of those as an example tomorrow. And one of these. But you've kind of got those are all the ones that use trig functions, right? The rest of them are special right triangles. You've got a pretty good template on what to do, don't you?
Yeah.
We're going to have tomorrow to work on this. Guys, I want to see a lot of work. I want you proving to me that you're doing this. Very big on that. Because this is an assignment that I plan on making worth 20 points. That I don't mind giving you an extra day. Because this is hard. But you have to do your part on your end. Okay? By doing a great job communicating that you know what you're doing. You guys understand that?
Yeah.
And I will grade very strictly on this. Okay? Because I've got them all drawn out for you. Really, all that's left is computations, isn't it? You've got a nice picture there that you can write on, that you can, work with. And that's why I made this a worksheet instead of not a worksheet. They're still not supposed to be in or around your ears, are they? You guess not. What? Okay, you just did. You promise? Okay. I'll believe you. Hey, I'm not being mean. With me, but you can see your frustration because this stuff's hard. I want you guys to listen. I want you to do well. Guys, we've got 5 weeks left.
Oh my fast.
5-6 weeks left of school, okay? And maybe 6 if you count this week. But the point I'm making is, if you count finals and stuff like that, the last week, we're probably not doing new material. Guys, please don't flunk a class because we have to, because you stopped 6 weeks early because, especially, and this has been a tough deal for everybody, but, because you kind of a weird thing getting the 2 weeks. It was weird for us too. Trust me. Okay? But let's make the best of a situation and let's do well. Okay, I want you guys to do well. If you have any questions, we've been recording this whole time, so I'll upload that. All right? And so hopefully it can